Welcome to the 2017 mock exam paper walkthrough. Just kidding, it's not going to be that boring, although it probably will be quite boring in bits. I'm going to be going through the papers. You should be using these with your papers in front of you, correcting any mistakes you've made. This video is trying to be somewhere in between teaching you how to do all the topics and just a mark scheme for the paper. Before we get started, I thought I'd give you a few tips on the best way to use this YouTube video. Firstly, I've tried to edit it so that it runs fairly quickly, but obviously there's a lot of questions, it's still going to take some time. So if you're finding that I'm talking and going through it a little bit slowly, you can change the speed of this video. If you're using a phone, just have a look at the video settings by clicking the few dots on the top, and you can change the playback speed. I recommend something like 1.25 times. If you're using a computer, you can hold down the Shift key and press the greater than symbol, and it will speed up your video every time you press it, or the less than, and it will slow it down. Also, if you're only looking for specific questions, if you have a look at the YouTube video description, you'll see some links that take you to each question individually. During this video, because I'm explaining some of the topics, I might be writing a little bit more down than you need to, but to give you an idea of what you need to do, in the bottom corner you'll see how many marks each question is worth and how many marks I've currently got. That number will go up every time I get a mark, and that includes method marks. You'll also hear a little sound, so you can see after I've written something down whether that was worth a mark in itself. Now I'm sure you're as excited, if not more, than I am to get started on these questions, so let's get going. Okay, let's get started with question 1. Work out the value of 2 to the power of 4. Now don't get confused, this isn't the same as 2 times 4. This is 2 to the power of 4, which means it's 2 times by itself 4 times. So working this out, 2 times 2 is 4, times 2, 8, times 2, 16. Question 2. Write 7.26451 correct to 3 decimal places. What this question is asking for then is a number with only 3 decimal places. If we think about where this number is on the number line, and we look at the numbers that are 3 decimal places, this whole number is actually in between 7.264 and 7.265. Because the next digit is a 5, that means that this number is actually just past halfway on this number line. That means if we had to write a number with only 3 decimal places to represent this one, the best number we can use is 7.265, because it's actually closer. So our answer is 7.265. It's only worth 1 mark, so you don't need any working. Question 3. Part A, we need to simplify 7 times E times F times 8. Now, this means that we're multiplying 4 numbers together. We don't know the numbers E and F are, but we do know there's a 7 and 8. 7 times 8 we can do, that's 56. Now we need to multiply that by E and F. Now in algebra, we don't need to show multiplication signs. If 2 things are next to each other, with nothing in between, that means they've been multiplied together. So our answer is going to be 56 E F. In part B, we're told that x divided by 5 equals 2.5. It might be easy to think of it as x divided by 5 equals 2.5. So we have to figure out what number divided by 5 is 2.5. To figure out what number divided by 5 makes 2.5, we need to work backwards and do the opposite. So we're going to times both by 5. So the original number is 5 lots of 2.5. So to figure out what 5 lots of 2.5 is in your head, you might want to first find out what 2 are. 2 lots of 2.5 is 5. Double that again, so 4 lots of 2.5 is 10. And if I want 5, I need an extra 2.5. So my answer is going to be 12.5. Question 4. Write 4/5 as a percentage. So we're converting fractions into a percentage. There's a few different ways of doing this. You might want to just find what 4/5 of 100 is, because percentages are out of 100. What I like to do when turning a fraction into a percentage, because I know percentages are out of 100, I'm going to try and make the denominator into 100. I'm going to do this using equivalent fractions. So if I start with 4/5, to find an equivalent fraction I need to times the top and bottom by the same number. And I want to end up with the bottom number being 100. I could start by timesing the top and the bottom by 10. That will give me 40 out of 50. And then all I need to do here is times the top and bottom by 2. That gives me 80 out of 100. So my answer is 80%. You could have done this in one step. You could have noticed that 5 times 20 is 100 and done it by timesing top and bottom by 22. So only 1 mark, so all they're looking for there is the answer. In question 5, we need to find 60% of 70. This is worth 2 marks, so we want to make sure we show some method rather than just writing down an answer. If I want to find 60% of 70, again there's a few ways to do it. I would start off by first finding out what 10% is. 70 is 100%, so to find 10% I need to divide it by 10. So 10% is going to be 70 divided by 10, which equals 7. So 60% is going to be 6 lots of 7, which is 42. The reason we're showing our working is that if we make a mistake, let's say we accidentally divided 70 by 10 and got something silly like 8, but kept using that number, we'd still get a mark because we were trying to do the right thing even though we made a mistake. Question 6, we get our first probability question. This question is a little sneaky. A lot of people got tripped up by this one. Sammy spins a fair 4-sided spinner. On the probability scale we need to mark with a cross the probability that the spinner will land on B. Now a lot of people didn't look very carefully. They've actually put in 2 B's on this spinner, which means that out of the 4 things, 2 of them are B's, so half of them are B's. That means the probability is going to be a half. In the second part we need to mark with a cross the probability that the spinner will land on F. There aren't any F's on the spinner, so that probability is 0. Question 7. Fahima buys 2 packets of bread rolls, costing £1.50 each, 1 bottle of ketchup, costing £1.60, 3 packets of sausages. Hang on, she's bought 2 packets of bread rolls and 3 whole packets of sausages.
Greedy much?
Anyway, she pays with a £10 note and gets 30p change. She works out that 1 packet of sausages costs £2.30. Is she right? You must show how to get your answer. Now this is worth 3 marks, so we need to make sure we're showing a lot of working, and they've asked us if she's right, so we need to make sure we end saying whether she's right or not, and we must remember to include some numbers to show why we think that. Now in a question like this, the easiest way to show if she's right or not is to find out how much the sausages cost. There are some other ways of doing it, but I think that's the easiest. So let's get started. Firstly, the bread rolls. Now the bread rolls are £1.50 each, and there are 2 of them, so 2 lots of £1.50 equals £3. 1 bottle of ketchup, that costs £1.60. She also buys 3 packets of sausages, we don't know how much they cost yet, and when she pays with a £10 note, she gets 30p change. So let's start thinking about everything that would add up to £10. It would be the bread rolls, the ketchup, the sausages, and the 30p. These are all going to add up to £10. If we add up what these numbers make, we can take that away from £10 and find out how much all the sausages cost. Adding these up, 0, 6 and 3 make 9, and 3 and 1 make 4. The total cost of the bread rolls, the ketchup, and the change is £4.90. Now we need to take this away from £10, so £10, take away £4.90. You could probably do this in your head. Otherwise, subtracting 0 take away 0 is 0. We need to do 0 take away 9, which we can't do, so we're going to steal 1 from the next numbers, meaning 10 take away 9, which is 1, and 9 take away 4, which is 5. So the sausages must cost £5.10. She buys 3 packets of sausages, so we need to do £5.10 divided by 3. Not the easiest division to do. Let's think about what number times 3 is going to make £5.10. It's going to have to be less than £2. 2 times 3 is 6. 1 times 3 is 3, so it's going to be £1 something. So we still need to make £2.10. You can try some numbers. For example, 3 lots of 50p is £1.50, not quite enough. And you'll end up finding out that the number is £1.70. 3 lots of £1.70 will make £5.10. Now it's not enough just to stop there. The question did ask, is she right? So the easiest way to answer that is to say, no, she isn't right. Sausages cost £1.70. Question 8. Fractions. You must revise fractions. There are rules that you just need to know, and it makes these questions a lot easier. For example, in the first one, we're timesing 2 fractions together. If you've done your revision, you know that when you multiply fractions together, all you need to do, times the top numbers and times the bottom numbers. 5 times 3 is 15, 8 times 4 is 32. Next, we've got to subtract 2 fractions. Again, if you've done your revision, you know that if you add and subtract fractions, you must make sure the denominators, the bottom numbers, are the same. So if we're going to do 2/3 take away 1/4, to make the denominator the same, we need to use equivalent fractions. The trick here is to times the first fraction by the denominator of the second fraction. So I'm going to times the top and bottom by 4. And for the second fraction, I'm going to times by the denominator of the first. So times the top and bottom by the 3. This way, our denominators are going to be the same. 3 times 4 is the same as 4 times 3. Both of them are 12. So my fraction now becomes 2 times 4 is 8. 3 times 4 is 12. Take away 1 times 3 and 4 times 3. I now get 8/12. Take away 3/12. Because I used equivalent fractions, this is just the same question. 3/12 is exactly the same as a quarter, but now the denominator is the same, so it's a lot easier to work out. I just need to do the top number, take away the second top number. 8/12 take away 3/12 leaves us with 5/12. Okay, question 9. Sean works for a company. His normal rate of pay is £12 an hour. That's pretty good. If we look at Britain's minimum wage rates, just as an extra bit of information, assuming that he is 25 and over, the minimum wage is £7.50 at the moment. You guys, minimum wage is £4.05. Although in April this year, that's going to jump up to £4.20. So if you're on minimum wage, you can expect an increase in April. Make sure your boss gives it to you. But back to the question, when Sean works more than 8 hours a day, he's paid overtime for each hour that he works more than 8 hours, which is just saying that after 8 hours, he's paid extra money for each subsequent hour. Sean's rate of overtime pay is 1.25 times his normal rate of pay. Now on Monday, he worked for 10 hours. Work out the total amount of money Sean earned on Monday. Well, first let's start with his normal rate, the first 8 hours. For the first 8 hours, he's paid at a normal rate. So he is paid 8 times £12, which is £96. He worked for 10 hours, so he's got 2 hours of overtime pay. Now he gets paid 1.25 times his normal rate. So his overtime pay is going to be £12 times 1.25. Well, a quarter of 12 is £3. So if he gets 1.25 times, he'll get an extra £3 on top of that, which is £15. So he's getting 2 lots of £15 for those hours, which is £30, giving him a total pay £126. Not bad for a day's work. If he does 2 of those days, he can buy himself a Nintendo Switch. Question 10. A farm has 20 boxes of eggs, and there are 6 eggs in each box. Write as a ratio the number of eggs in 2 boxes to the total number of eggs. You then have to give your answer in its simplest form. So we need to know how many eggs are there in 2 boxes first. Well, there's 6 eggs in each box, so that means there are 12 eggs in 2 boxes. It's a ratio, so we should write this with a colon. And then we need to know the total number of eggs. So we need to do 20 times 6. With a little bit of thought, we can find that that's 120 eggs. So now we've got the ratio of eggs in 2 boxes to the total number of eggs. There are 12 eggs in 2 boxes and 120 total number of eggs. To write this ratio in its simplest form, what we need to do is divide both of those numbers by the same number until we can't divide anymore. So we need to think of a common factor between 12 and 120. Hopefully it's quite obvious looking at both these numbers. They can both be divided by 12. Dividing the first one by 12, we get 1, and 120 divided by 12, we're going to get 10. Now we've run out of common factors, so we can't divide the numbers any further, so our answer is 1 to 10. Question 11. A series of patterns is made from circular tiles and square tiles. Here are the first 3 patterns, and we need to find out how many square tiles are needed to make the 6th pattern. So looking at the square tiles, in the pattern number 1 we've got 1, pattern number 2 we've got 4, pattern number 3 we've got 9 square tiles. You might notice these numbers are the square numbers, or you might just figure out that because we're basically finding the area, in pattern number 3 for example, we've got 3 rows of 3, so we're going to have 3 times 3 tiles. So to make pattern number 6, we're going to need 6 times 6 square tiles. Well, that's the same as 6 squared, 36 square tiles. So how many circular tiles need to make pattern number 20? Well, for the circular tiles, we've got 4 in number 1, we've got 8 in number 2, and then 12 in number 3. And if we look, for example, at pattern number 3, we've got 1, 2, 3 circular tiles on the bottom, and we're going to need the same for every side of the square. So we're going to need 4 lots of 3, which gives us 12. For the 20th pattern, we'll have 20 circles along the bottom, and then we need to multiply that for each side of the square. 20 times 4, we're going to have 80 circular tiles. And then for part C, Derek says,
When the pattern number is odd, an odd number of square tiles is needed to make the pattern. Is that right? Make sure you give a reason for your answer for the 2 marks. Think about the 2 we've seen up here. The odd numbers are 1 and 3. In this case we have 1 square tile, 9 square tiles, which seems to fit with what he says. We already said that these are the square numbers, so what we're looking for, the number of tiles, is all the odd numbers squared. We know, because we've done our revision, that odd numbers times by odd numbers will always make an odd number. And we're going to write this for our answer. Yes, he's right, because odd numbers times by odd numbers always make odd numbers. Moving on to question 12, we've got a probability question. There are only 7 blue pens, 4 green pens, and 6 red pens in a box. 1 pen is taken at random. What's the probability that that pen is blue? When we give a probability, we usually write it as a fraction, and we need to know that to give the probability of an event, the numerator, the top number, is going to be the number of desired outcomes, and the denominator, the bottom number, is going to be the total number of possible outcomes. In this case, because we're looking for a blue pen, there are 7 blue pens, and that's out of a possible, and adding all the pens up, 7 plus 4 plus 6, giving us 17. 7 out of 17. The method mark in this question is if you get either the 7 or the 17. 2 marks for both. Question 13. It's an interesting question because question 13 requires you to have a basic bit of general knowledge, I suppose. The diagram shows a tree and a man. It tells us this man is of average height and the tree and the man are drawn to the same scale. Now it says write down an estimate for the real height in meters of the man. Because the man's average height, they're basically saying write down an estimate in real height in meters of a man. What's the average height of a man? Now this question is actually quite generous. In the mark scheme they allow you to have the height of a man anywhere from 1.5 meters all the way up to 2 meters. This is really quite generous because a 1.5 meter man would, for example, be the very short Danny DeVito, and a 2 meter man would be a very tall Richard Osman from Pointless. So as long as you put a number somewhere between 1.5 and 2 meters, you'll get the mark. With a little bit of research on the internet, I found the average height of a man in the UK is 1.75 meters. I'm going to put down 1.8 because it's going to be easier to use later. Now for part B, they want you to find an estimate for the real height in meters of the tree. So we need to use our number to estimate how high this tree is. So what we need to do is figure out how many of our man equal the height of this tree. You could use a ruler to measure the man and measure the tree, but with the magic of technology, I can show you that this tree is about 5 of these men. So, as we wrote down earlier, the height of our man was 1.8 meters. We need to find an estimate by saying it is 5 lots of 1.8. You'll get the method mark as long as you use a scale factor of 5 or 6. So as long as you said the tree was about 5 or 6 people tall, anywhere in there. Times these numbers together. You could use the grid method, Chinese grid method, any way you want really. The way I might think about it is 10 lots of 1.8 is 18. As I want 5, I need half of that. So I'm going to say the tree is 9 meters. Alright, question 14. Pie chart question. Hope you brought your protractors with you to the exam. Year 9 students from Hale School were asked to choose one language to study. The table shows the information about their choices. So 56 students studied French, 40 studied Spanish, and 24 studied German. We need to draw an accurate pie chart to show this information. First, we need to find out how many students there were in total. Adding 56, 40, and 24, we're going to get 120 students. Now to be able to draw a pie chart's having 360 degrees in total, we need to know how many degrees is each student worth. Now if the total number of students is 120 degrees, and there are 360 degrees in a circle, what I need to know is, out of those 360 degrees, how many do I get if I divide all of those by the 120 students? Basically saying how many degrees does each student get. 360 divided by 120, we can see that 320s makes 360. So each student is worth 3 degrees. So if we want to know how many degrees 56 French students are going to be, we're going to have to triple it because each student's worth 3 degrees. So 3 lots of 56 is going to give us 168. 3 lots of 40 is going to be 120. And 3 lots of 24 is going to be 72. A quick check to make sure we haven't made any mistakes. By adding these together, we can see that we do get 360 degrees. As this is a non-calculator exam, they've given us some fairly nice numbers to work with. If this turned up in a calculator paper, you might expect some nastier numbers. Now we need to show these on the pie chart, so we have to draw them in. Let's draw French first. That's 168 degrees. So, to draw this on our pie chart, we're going to need to get out our protractor, and here it is. Now, to place our protractor onto the pie chart, we need to make sure first the centre of our protractor is right in the centre of the pie chart, and we want the 0 to be in line with our line, so right at the top there. So there we go, and we want to do 168 degrees, so making sure we're using the same numbers that started at 0, so going along the top, we're going to go all the way along until we get to 168 degrees, which is going to be right about there. Removing our protractor, we can now draw a nice straight line starting in the middle and going past the point we marked for 168 degrees. Don't forget that once you've made a region, you must label it, otherwise that region could be anything. In this case, we're looking at French students. We can do the same thing now for our Spanish students, making sure 0 now is lined up with our new line. We need to measure 120 degrees from there, which will take us right there. And we don't need to measure the last one because that's what's left. So there are the German students. In the next part of the question, they tell us that Year 9 students from Lowry School were asked to choose one language study, and they give us a pie chart for that. They tell us that Shamina says the pie chart shows that French was chosen by more Year 9 students at Lowry School than at Howley School. Now, although it's true that the French part of the pie chart is larger, all that tells us is that there was a larger proportion of students that took French. Whereas Shamina's just saying that there were more students that took French. This isn't true. Lowry School could be a very small school, so even though the pie chart shows that more than half of them take French, if Lowry School only had 12 students there, very few of them would actually take French in comparison to Howley School. So to explain your answer, you need to write down something like, we don't know the actual figures for Lowry. Question 15. We've got a triangle and a rectangle. The question tells us that the area of the rectangle is 6 times the area of the triangle. Work out the width of the rectangle. So you must have memorized your formulas for the area of a triangle and the area of a rectangle. Area of the triangle, a lot of people keep forgetting. You times the height and the width together, and because it's half the size of a rectangle, you have to half your answer. So, area of triangle is 9 times 8 divided by 2. 9 times 8 is 72. Divide that by 2 and you get 36. It tells us the rectangle is 6 times the area of that triangle, so we need to times that number by 6 to get the area of the rectangle. So for the area of rectangle, we're going to do 36 times 6. Personally, I like the Chinese grid method for difficult times tables. I'm going to do a very quick one over here. 36 times by 6. Draw myself a box, and I divide each square into 2. Now I can do 3 times 6, which is 18. 6 times 6 is 36. Now I add up diagonal columns. We've got 6. 8 plus 3 is 11, so I carry a 1, and just a 1 there. The carried 1 makes that 2. So I've got 216. Now the area of a rectangle is its height times its width. Now for some reason in this diagram they've drawn the width going up, doesn't really matter. I just times the two sides together, so 16 times whatever the width is will give me the area of the triangle. So I need to figure out 16 times what is going to make 216. So to do that, we're going to do some division. You might want to do some long division here. So the width is going to be 216 divided by 16. Maybe you might want to do this as long division, bus stop method. We can see that 16 will go into 21 once, and it's going to leave 5 left over. How many 16s are going to go into 56? That's a little trickier. We might want to go through our 16 times tables. So 16, add another 16, that's 32. Add another 16, 48, plus another 16, we get 64, which is too many. So we can fit 3 of those in, but we're going to have some remainders, so we're going to have to keep going a little bit. How many left over? Well, to make 56, we managed to get to 48. We're going to need 8 more to bump that up to 56. And now we need to think how many 16s are going to go into 80. Well, 16 times 5 is 80, so we're going to get 5 left over. So our final answer is 13.5 centimetres.
Well, I hope you enjoyed the first half of the paper and found it helpful. Stay tuned for the next installment. Don't forget to like and subscribe.